student senior teaching. Overloading occurs when two or more methods in one class have the same method name but different parameters. It related to compile time polymorphism, which again I'm going to explain more in the polymorphism slide. The advantage of this is it gives programmers different ways to construct an object of that class. It also increases the readability of the program. In my example code on the right, we created two methods. The first add performs additions of two numbers, int a and int b. The second add performs three additions, int a plus int b plus int c. Notice how the int add they both have the same name. That's overloading right there. And when we system out print, we are using the same name, adder.add, and we put the numbers that we want. For the example, we have 10 and 20, and then the other adder.add, we have 10, 20, 30, and it outputs 30 and 60. Overriding means having two methods with the same method name and parameters. One of the methods is the parent class and the other one is the child class. Overriding allows child classes to provide a specific implementation of an object that is already provided in its parent class. So on the code to the right, I have an example. The vehicle variable is being declared to be vehicle. So in the bottom, we can see that vehicle equals new car. During compiling time, the compiler checks if the vehicle class has the color method. So that's why it says in the bottom of the object, the new car, parentheses, it says vehicle.color. So it's trying to see if the vehicle class has that color method, which it does. And as long as it has that method of color, the code compiles. And at runtime, a car is created and assigned to vehicle. The JVM knows that vehicle is referring to the object of car, so it calls the color method of car of car. This is called dynamic polymorphism, and polymorphism only applies to overriding, not overloading. Another advantage to overriding is that it doesn't need to be. We don't need to modify the parent class code. It provides multiple implementations of the same method and can invoke parent class overridden method using super keyword. And again, polymorphism is only being applied in overriding, not overloading. And I'll explain more about polymorphism in the other slide. Static field is the declaration for a variable that will be held in common by all instances of a class. For example, if an instance of a class cat receives an instance variable green, then it will be this will indicate that a cat is green. If applied static field, it would indicate that all cats are green. So in my code to the left, we have the static field unique ID, right? We have the static right there, int unique ID equals 1. So this holds the value 1, and that value will be the same across all item objects. So if there are 100 item objects, there will be 100 instances of the item ID and item name fields, but only one unique ID static field. An array holds data values of one single type. It allows to store access large number of values covenantly. Declaration. So in order to declare an array, we need the type of array and the name. So the type declares the element of the array, which we could use int, char, float, string, etc. The name of the array, which could be anything. And yeah, so in the example on the right for the top one, we have the int grades. So the int is the declares the type of elements. So it's just numbers, followed by the name, array, which is grades, the grades. and the brackets equals new int 4 bracket. The 4 just means how long the array is gonna be. So the index, it starts from 0 and it continues. So in this case, we're setting the grades bracket 0 equal to 90. So those are 4. And in order to print out one, we use system.out.print, and we put grades brackets 3, which is which index it is. In this case, it's 3, which is gonna print out 100, as you can see below. So on the code to the right, below, that's the easier way. Most people declare an array. So we put public class grades, and we put int grades, like the same int grades brackets equals, and with curly brackets we put the the ints, all the numbers that we want in. So in this case, I want 5 int grades, which is 90, 50, 60, 180, and I just put them there followed by commas. And it'll be easier for me to spit out to print out which one I want. So I want to print system out print grades 1. It was gonna print out the number 1, which in this case it's 50. So you can see below there, the 50 is system out. Final constant is a variable whose value cannot be changed once it has been assigned. So we add the final in front of the variable declaration to define a variable as constant. A constant can make our program more easily readable and understood by others. In addition, a constant is cached by the JVM as well as our application. So using a constant can improve our performance. So on this code, I have final int variable 1 var1 equals 2. So the var1 will be 2 always. So that's why I have put final on all of them. So when we output them, the value of var1 through var4 will stay the same when we first initialized it. So on this code on the left, I took off the final of the int variable 1 equals 2, and then I made var1 equals 100 in the lines below. So when I want to call and print var1, it's gonna print 100, which was the last var1 declared. That's why final is important. If we put final in front of the int variable equals 2, then that will be, so var1 will always be equals to 2. Like even though I put var1 equals 100, later on it's not gonna be able to change. That's why there's on the right there's var1 equals 100. That's why there's a red line on the bottom, because I put final in variable. So at final var1 final in var1 equals 2, that would always be 2, and it won't change when we put another var1 later on in the code. Format specifier defines the type of data to be printed on the standard output. Format specifiers start with a percent character and end in the type character, indicating the type of data, which int, float, etc. So the example I'm going to give on my code is going to be a sign specifier. But on the table on the right hand side, there is a table with all the format specifiers available. But for this example, I'm going to be using sign specifier. For a sign specifier, so this adds the plus sign before positive numerical values, and it has no effect on negative numeric values. So what I mean here is when we create a new formatter, we have the percent plus d, which is, well, comma 77, which is the sign specifier there. So when we print it out, system print, we're gonna type again the parentheses plus d, which is gonna be printed out as plus 77, which is positive 77. But if we put negative 77, it will have no effect on it. So I tried this on the code. I tried putting parentheses, not parentheses, percentage negative d, and it gave me an error. So I left it as percent plus d, comma negative 77. So it could system out a negative 77. So this is the sign specifier. Polymorphism is the concept of one identity providing multiple implementations based on the object that is acting upon it. It allows you to define one interface and have multiple implementations. So usually polymorphism is divided into two types: compile type polymorphism and runtime polymorphism. So my example code on the right is an example of a runtime polymorphism. So it allows you to define one interface and have multiple implementations. As we can see here in the example, we have defined the method noise and have multiple implementations of it in different subclasses. So here we have, like I stated, noise on the class animal, and the system printing out animal makes a noise. So on the other main class, it extends animal. So I created a class called turtle, which extends animal, and it's gonna system out print moo. I don't know what turtles made, so I'll just put moo, the noise. And then we created an object, animal object equals new turtle, and when we call that object dot noise, it would print out moo. So the most important part is the part where it extends the interface of animal. Again, this is a runtime example of polymorphism.